Okay, welcome back. Happy Friday. Today, April 22nd, we're going to talk about quadratic models. Everything that we do today is going to involve word problems. That's the modeling part. But instead of having word problems that result in linear equations, which is what we did for basically the first half of the semester, the word problems today are going to involve what kind of equations? Quadratic equations, right? And we know how to solve quadratic equations, but the word problems are going to involve these more complicated quadratic things instead of linear things. Coming up on Monday is our quest, but just to be clear, the material from this thing that we're about to do is not on the quest. Questions on the calendar? Okay. So starting here at the top of page 204 with our summary. In this lesson, we tackle some word problems that lead to quadratic equations. Today's activity is long, so let's go through the demo quickly. Here we go. All right, so here's the idea. We're going to take a square piece of cardboard, starting here, square piece of cardboard, and we're going to cut 4-inch squares from each corner of that square piece of cardboard. And we're going to fold up the sides, and we're going to do this in front of you. So here's my square piece of cardboard. I'm going to cut 4-inch squares. Now I don't have 4-inch squares that I cut, so just pretend that's a 4x4 square. And we're going to cut that from each of the 4 corners. And we're going to get this kind of plus sign shaped looking thing. This. And then we're going to fold up the sides. Like so. And then right before your very eyes, my 2-dimensional piece of paper becomes what? A box with no lid, right? So that's the setup. What is it? It's not a boat, this is a box. Come on, stop using your imagination. Okay, so that's the setup here, right? Now, how much volume is in this box depended on the size of the original piece of paper, right? If I start with a big piece of paper, I'm going to have a bigger box. If I start with a really tiny piece of paper, I might have a really tiny box here. And so the question is, if you want the box to hold 100 cubic inches, that is to say, the volume is supposed to be 100 cubic inches, how big of an original piece of paper should I start with? That's the question we're going to solve, okay? We want to know how big the original piece of paper should be. All right, Emma, this is for you. There you go. All right, so we're going to do some reading here. The first picture is the square piece of paper, and then we cut out these light pink 4x4 squares from the corners, and we fold it up, and we get our open top box over there on the right. Okay, so we'll first introduce a variable. The variable is going to be the, so the question asks for the dimensions of the square. So how about we'll let B represent the dimensions of the square. So that's the original side. And okay, so there's our definition. B is the length of a side of the square. Before it's cut in inches, remember we're always putting unit words in our definitions. The box is to hold 100 cubic inches. That is the volume. What's the formula for the volume of a box? Length times width times height. So we've got that written out here. Okay, let's see if we can figure out what these guys are. Now it's written down below, so don't look. So volume equals length times width times height. I'm going to leave the length blank for a second. I'm going to leave the width blank for a second, but we're going to fill in the height. What's the height of that box? It's the 4 inches, right? The 4 that we folded up, right? We cut out a 4 and then we folded it up. So everybody buy, it's got to be 4 inches is the height. Now the length and the width, well, they depend on the original size of the square. So let's think about this. Originally, we had B representing the whole side, right? And then we cut out some squares from the corners and eventually ended up with like this distance right here, which I'll call L for length. So what is the length in terms of B? 4 minus B? B minus 8? I'm seeing more B minus 8s, right? The whole B, and then we don't just subtract a single 4, but we actually subtract 2 4s. And then whatever is left over, I'll put in another color here. This piece is the guy that ends up there, right? So B minus 8, I buy it. That is the length. Yeah, Jeff? Yeah, that was weird. Mhm. Yeah. No, it's definitely square, but B was the original side of the square, and we cut some stuff out. And so B is not the length of the box. The box has a shorter length. Come back to our 3D thing here. Like this guy right here, maybe it was originally, I don't know, 6 inches or something. Yeah. Okay. All right. So that is that. What about the width? I'll call that this guy right here. What's the width? Which I would say comes from this thing right here. It's also b minus 8, right? It was a square to start with, and we did the same thing. So this is another b minus 8. So right there is our formula for the volume. But we know what the volume is supposed to be as a number. What is it? We want it to be 100. So we're going to have 100 equals all this stuff. No, the units will all work out, but it's a good thing to think about. What are the units for the length? For just the length? Just the length is inches, right? That's a one-dimensional thing. How about the width? Inches. How about the height? It's also inches. So cubic inches. It all works out. Yep. Okay, so let's distribute on the right-hand side. Lots of distributing on the right-hand side. I'm going to do multiply these two guys first and then the 4 at the end. So either lobster claw or 2x2 box or foil or just distributive. What do I get for these two guys? B squared. These two guys? Negative 8b. These two here? Another negative 8b. These two? Positive 64, right? So that's what we get when we distribute. What did we forget? Yeah, we will combine like terms. But the 4, don't forget the 4 hanging out here. It doesn't go away. Go distribute the 4 now. I'll combine like terms first. Actually, the smartest thing to do is to get rid of that 4 by doing what to both sides? Divide both sides by 4. Like that would be the best thing to do. We're gonna distribute it. So in case you don't see that you can divide by 4, but dividing by 4 will just make a nice, simpler equation. Okay, 100 equals b squared. When I combine the two terms in the middle, negative 16b plus the 64, and that is multiplied by 4. And now we'll distribute that 4 in. 100 equals 4b squared minus. So this 4 is coming in and hitting all 3 of these guys. What do we get? 16 times 4, that's 64b plus 4 times 64, 256. And then finally, I can catch my breath and say, hey, what kind of an equation is that? That's a quadratic equation. How can you tell? Because of the square, right? It's got a b squared in it. That's a quadratic equation. And we have techniques for solving quadratic equations. Almost all of the techniques involve getting what number on one side? It's a 0. So let's bring that 100 over to the right-hand side. 0 equals, so we're subtracting 100 from both sides, 4b squared minus 64b plus 156. Now we've seen several tools for solving quadratic equations. The one that's the most powerful is the quadratic formula, because that will work on every equation, right? But it's also the messiest one. And if the thing factors, then oftentimes that's simpler and less prone to error than the quadratic formula. So let's try to factor. What's the first kind of factoring we're looking for? I'll give you the 3 choices. We have 3 kinds of factoring. There's the box method, the 2x2 box method. There's the factoring out the greatest common factor. and then there's the difference of two squares formula. One of them always comes first. Which one? It's the greatest common factor. That's always what we do first. So we're looking for something that goes into all three terms. What is that something? 4. So let's put 4 and then big parentheses. We'll fill in what's in the parentheses. So what comes first? B squared minus 4 into 64, 16b, 4 into 156, 39 is good. If we had done that, remember when we distributed the 4 up there, the purple? If we had divided by 4, we would have jumped to that thing in the parentheses down here. So. Okay, so we factored out the greatest common factor. That's great. And now the only two options left are the 2x2 box method of factoring or the difference of two squares. Is this a difference of two squares? No, it's not even 2, right? It's 3 terms. So the only option we have is the 2x2 box method. Let's give it a shot. Okay. The b squared, we're ignoring the 4 for right now. I mean, you could divide by 4 now if you want. But the b squared, where does that go? Top left, b squared is here. How about the minus 16b? What is that? Let's put that down here. That was the sum, negative 16b. Plus 39 goes where? Down right. And then we've got something off on this corner, off the bottom right. That's the product, which is 39b squared. So this is often the hardest part for folks, is finding things with the right sum and the right product. But I encourage you not to try to look at both of those at the same time. Just focus on which one. The product. Always focus on the product. So we just list. There's not that many factors of 39. What are they? So it could be 1b and 39b, or 3b and 13b. Now, ostensibly that's all of them, but this assumes that everything was positive. What's the other way you could get things to multiply to positive 39? If both negative, right? So I'm going to list negative 1b, negative 39b, just the same exact things, negative 3b and negative 13b. So there's only 4. And we'll list them all, and we're looking for the winner that has the sum of negative 16b. Which one is it? Last one. So we just put those two guys in any order. It doesn't matter what order, but just copy my order so we're all looking at the same thing. Okay. And now we're going to look in the first row and pull out the greatest common factor. So what goes into both things in the first row? Just b, right? And then everything else is determined. What can I put up on top here to build the b squared? It's got to be a b. What am I putting on top here to build the negative 13b? It's a negative 13. What are we putting at the bottom left to build the negative 3b? Negative 3. And then we cross our fingers. How do we check our work? Yeah. Can you confirm that 39 is what you get? It is. Super. So I'm now going to go back to blue, and I'm going to copy our new result from this equation. 0 equals 4, and then 2 parentheses. What goes in the parentheses? b minus 3 and b minus 13. And then we just have a tiny bit left to do in this problem, right? We just need to find the values of b, and so this is where we split into our different equations. Now we're out of time for right now, so we're going to finish this problem on Friday. It's essentially done, but there's just one extra thing I need to say about it, and I don't want to keep you guys late, so we'll pick up right here on Friday, okay? All right, so this homework is not assigned, it's not due, it's not anything. We'll see you Friday.